Hello. We're going to need to write ionic compound formulas from their chemical name, and we're going to need to name chemical formulas that are ionic compounds. To write the chemical formula for an ionic compound, we need to be able to use the charges of the two ions in the compound to find the subscript needed to make a neutral compound. First, we must have written down the chemical formula of the cation and its charge, and the chemical formula of the anion and its charge. Once we have that, we have a couple of methods we can use. Method one, we can use ion blocks. And in an ion block, we're determining what kind of cation block from the metal, what kind of anion block from the nonmetal, and we'll combine them until balanced. So if we had aluminum plus 3 cation and oxygen minus 2 anion, if we started with a plus 3 ion block and added one negative 2 ion block, we can see that they are not balanced. We need more negative charge. But if we add a second negative block, we realize we now are short on positive charge. We add another positive ion block, and we need one more ion block to finish. When we're done, you can see that we have 2 aluminum plus 3 cations and 3 negative 2 oxygen anions needed to make a neutral compound. That gives us a ratio of 2 to 3 and a formula of Al2O3. You can see a couple other examples here on the screen. The other method is to guess the subscript and then check if the charge is balanced. To be neutral, we know that the total positive charge has to equal the total negative charge. And the total positive charge is the subscript of the cation times its charge, and the total negative charge is the subscript of the anion times its charge. Of course, we'll use absolute values, so we're not concerned about the sign, just the total value. So we're going to guess a set of subscripts, then check it by multiplying within the chemical formula. Calcium plus 2 combined with chlorine minus 1. We're going to guess at the subscripts. I'm going to guess a 1 and a 2. Then we're going to multiply the charge times the subscript for each ion. On the left side, I have 2. On the right side, 2 times negative 1 is negative 2. And I'm going to check that they're equal. Of course, I'm going to ignore the sign of the charge since we're using absolute value. 2 and negative 2 are same value if we ignore the sign. So this is balanced. The question becomes, what subscripts should you guess? And the answer is you want to guess the value of the charge of the other ion. So remember that the product of two numbers is always a common multiple for them, but not always the lowest one. So if we use aluminum plus 3 and chlorine minus 1, for the chlorine, we're going to try a subscript of 3 because that is the charge of the aluminum ion. For the aluminum, we're going to try a subscript of 1 because that is the charge of the chloride ion. Note that 1 times plus 3 is 3, and 3 times negative 1 is minus 3, and if we ignore the sign, then we have an equal. Note that this is sometimes called the crisscross method because the charge of each ion crisscrosses down to become the other ion subscript. So we're going to use the charge of the other ion for the subscript. It's always going to work, but it may not always be the lowest subscript. So you're going to need to check if the subscripts can be reduced to a lower set. Okay, reminders. Your ionic compound formulas do not show ion charges in them. Your ionic compound formulas do not show subscripts of 1. And your ionic compound formulas show the lowest set of subscripts possible. So once you're done figuring out the subscripts, remember to rewrite your formula cleanly after you work them out. Okay, let's work a problem. This problem is, what is the chemical formula of magnesium phosphate? So we'll begin. We know that magnesium is a metal. That means this is ionic. This is important. It's really a big deal that you're checking that you actually have an ionic compound formula before you use the ionic compound rules to try to come up with the chemical formula. We know we need to write the formulas and the charges for each of the ions. So we know we have magnesium. That's a plus 2 ion because it's in group 2. We need to write phosphate. The 8 ending clues me into the fact that it is a polyatomic. Phosphate is PO4 and it has a negative 3 charge. And now we're going to guess subscripts. We're going to crisscross. So the 3 is going to become the subscript for the 3 of the phosphate becomes a subscript for the magnesium, and the 2 of the magnesium becomes a subscript for the phosphate. Note that we have a 4 and a 2 here. It's kind of confusing. It's important that if we have double subscripts, we're going to use the parentheses to contain the polyatomic ion formula. Now, when I look at the numbers 3 and 2, I cannot reduce further, so I can leave them alone. They're good. At this point, I want to just clean it up. Mg3, I don't need the charge. PO4, 2, I don't need its charge, and that would be my answer. So that's how we're going to come up with ionic compound formulas.